In our last lecture, we talked about the inverse of a function. Remember, we defined the inverse of a function as a function formed by interchanging the domain and the range of the given function. I gave you a handout dealing with finding inverses. Are there any there that gave you trouble? Number 11.
That's the one.
Okay. Number 11. What we have is f of x equal 7x plus 6 over 7 minus 2x. This is number 11. Well, we know that f of x is y, so we have y is equal to 7x plus 6 over 7 minus 2x. We're now going to solve this for x, meaning we want to get x all by itself. So our first step is to clear fractions. This is number 10. If we multiply both sides by the LCM, which is 7 minus 2x, we get y times the quantity, 7 minus 2x, equals 7x plus 6. Clearing parentheses, we have 7y minus 2xy equals 7x plus 6. Now remember, we are solving this for x. We want to get x all by itself. Now it doesn't make any difference which side you bring the x's on as far as the answer is concerned. But sometimes it's easier to bring it on one side rather than the other. Such is the case in this problem. What I'm going to do is I'm going to bring the x's on the right, and the terms that don't contain the x on over on the left. So that means on both sides of this equation I have to add a positive 2xy and a negative 6. If I do that, I have 7y minus 6 is equal to 7x plus 2xy. Now what we have to do is divide both sides by the coefficient of x, but we don't know what it is. So we're going to factor an x out of there. We get x times the quantity 7 plus 2y. Now we know what the coefficient of x is. It's what you're multiplying x by. So we're going to divide both sides by 7 plus 2y. We have x is equal to 7y minus 6 over 7 plus 2y. And that was the hardest part of the problem. Now we want to find the inverse. Well, we get the inverse by interchanging the domain and range. That means for every place I have an x, put in y, and for every place I have a y, put in x. So if I do that, I get y is equal to 7x minus 6 over 7 plus 2x. Notice we have it solved for y. Anytime you have it solved for y, you have it in functional form. This is a function. The name of this function is f inverse. So f inverse of x is equal to 7x minus 6 over 7 plus 2x. Okay? Okay, let's start reviewing. We started this unit talking about the Cartesian system. Now the Cartesian system is made up of two real number lines intersecting at 0 perpendicular to each other. Now what we did is we named the number lines. We said the horizontal number line is our x number line, or x-axis. The vertical number line was the y number line, or the y-axis. The point of intersection was called the origin. And the area that divides our plane up into were called quadrants. The upper right was quadrant 1, and we numbered them in a counterclockwise direction. We've said that this system deals with a branch of mathematics called Analytic Geometry, meaning it makes algebra problems out of geometry problems. And the first word we came across was point. We define point as an ordered pair of numbers. By ordered pair, we mean an xy. The first number represents how far you go on the horizontal number line. The second number represents how far you go on the vertical number line. We then said, hey, if we have 2 points, we're going to have a line. Any 2 points, distinct points, will give you a line. So let's take a look at 2 distinct points. On the board I have 2 points. A is the order pair -2, 5. B is the order pair 6, -10. I have a line. 2 points give us a line. Now this line has various characteristics. The first characteristic we talked about was the slope of the line, the steepness of the line. And we defined slope to be change of y over change of x. Or slope, which is m, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you see we have 2 points. What we do is we call one of these points 1, the other point 2. And as we illustrated past lectures, it doesn't make a bit of difference which point is point 1, which point is point 2. If A is point 1, then this -2 represents x1. I'm sorry, x sub 1 is -2, y sub 1 is 5. X sub 2 is 6, y sub 2 is -10. We now just plug in these values into our formula. So we have m is equal to y2, that's -10, minus y1, that's 5, all over x2, which is 6, minus x1, which is a -2, minus a negative is +2. So we get m is equal to -15 over 8. And there's the slope of this line. What this is saying that for every 50 units y goes down, x goes 8 units to the right. Okay? Now another characteristic we talked about in respect to this line is that there was distance between the points, the length of the line connecting these 2 points. And again, we had another formula we developed. It was the distance formula. And we said the distance is equal to the square root of the difference of the x's squared plus the difference of the y's squared. And this is our distance formula. Very, very important formula in math. Now what we're going to do, we're going to plug in these values and come out with the length of this line segment. So we said the distance of AB is going to equal, again, we call one point 1, the other point 2, and again, it makes no difference which is which. Since I already have numbered 1 and 2, I'm going to use this. It has x2, which is 6, minus a -2 makes it +2 squared. Plus y sub 2, well, that's -10, minus y sub 1, that's 5, 20 squared. It's now an arithmetic problem. We get the distance of AB would equal 6 plus 2 is 8 squared, 64. Plus -10, -5 is -15. You square -15, you get +2, 25. The distance of AB would equal the square root of 289, which is 17. On the board I have 2 points, the point 21 and the point 78. I have 2 points, I have a line. What I'd like to do now, I know how to find the slope of that line and the length of the line, and what I'd like to do now is find the name of the line, the equation of the line that passes through these 2 points. Well, we have 2 points. We have the 2-point formula. Now remember, we developed these formulas. 2-point formula says y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. So again, what we have to do is call one of these points 1, the other point 2. And again, it makes no difference which is which. This is 1, 2. We plug them in. It says y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. Okay? All I did was replace x1, y1, x2, y2 with their values. We now clean up the right side. We have y minus 1 over x minus 2 is equal to 7/5. We now want to get this in general form. By general form, we mean ax plus by equals c. Well, to do that, we have to clear fractions. We have a proportion here. Anytime we have a proportion, we can cross multiply. By cross multiply, it means I have 5 times the quantity y minus 1, which is 5y minus 5, equals 7 times the quantity x minus 2, which is 7x minus 14. We now get this in general form. We have 5y minus 7x equal negative 9. And this is the equation of the line that passes through these 2 points. Now to check it, all you have to do is plug in one of these points. In other words, let's use point 2. X is 7. Every place I have an x, I'll put in 7. Every place I have a y, I'll put in 8. It says 5 times y. Well, 5 times 8 is 40. Minus 7 times x. Well, x is 7. A minus 7 times 7 is negative 49. Hey, check. That's equal to negative 9. So you see 2 points. We have a line. We know how to find the equation of the line. Also, we've discovered that in order to have a line, you can have a 1 point and the slope of the line. In other words, if I give you a line that passes through the point negative 6, negative 3, and I say m is equal to negative 4/5. You have a point and you have a slope. Therefore, you have a line. Now again, we have developed the formula for point slope. We said point slope formula is y minus y1 over x minus x1 equal m. There's the formula. We only have 1 point, so this is x1, y1. We plug them in. We have y minus a negative 3 makes it y plus 3 over x minus a negative 6 makes it x plus 6 is equal to negative 4/5. We now cross multiply. Now remember, when you have a negative fraction, that means the numerator could be negative or the denominator could be negative, but they both can't be negative. I usually treat my numerator as negative. Cross multiplying, I have 5 times y plus 3, which would be 5y plus 15, equal a negative 4 times x plus 6 gives us a negative 4x, negative 24. Getting it in general form, we have 5y plus 4x equal negative 39. And there's the equation of the line that passes through the point. Negative 6, negative 3, and has a slope of negative 4/5. Now, we talked about parallel lines, perpendicular lines. We said that anytime anytime that lines are parallel, their slopes have to be the same. Slopes are equal. Parallel lines have equal slopes. We said that perpendicular lines their slopes would be negative reciprocals of each other. Okay? So if you know the slope of a line, you know the slope of any line parallel to it and perpendicular to it. Remember I gave you a set of problems dealing with parallel and perpendicular. You'll see one again tomorrow. Okay? Let's suppose I have a line 7y minus 4x equal 21. This is equation of a line. And what I like to do is I like to find the slope of this line. How can we find the slope of this line? Karen, remember how to find the slope of a line.
Solve for y.
See, it's nice to have Lynn next to you. Solve for y. Right, you solve for y. Get y all by itself. See what makes this so nice? When you solve for y, what do you have? Anytime you have an equation solve for y, what do you have?
You have the slope and the
Oh,
constant.
yeah, what do you have though when you have the equation solve for y? I heard it someplace. I mean, when you solve the equation for y, when you have y equal, what's another name for y? Function. Function. And that's what makes this nice, because all your equations after this course is going to be in functional form. In other words, your lines are going to be in this form. So as soon as you have the line, you know what the slope is. What is the slope of this line? 4/7. Anytime you solve it for y, or have it in functional form, the slope of the line is 4/7. So the slope of our given line is 4/7. What would be the slope of any line parallel to this line? 4/7. Sure. Parallel lines have same slope. What would be the slope of any line perpendicular to this line?
Negative 7.
-7/4. Okay? Nice. Simple. Now, we talked about graphing a line. Graphing. Drawing the picture of a line. So let's take a look at one. 2x plus y equal 5. Now we had three ways of graphing. The first method was the 3-point method. Find 3 points that are on this line. Find 3 order pair that satisfy this equation. And, well, that's no big thing. It's a long process, but not that difficult. We have to find 3 order pair. So what we do is we assign a value to one of the variables. Assign one. Whatever you want, whichever variable. I keep the number small because I'm going to have to draw the picture, the graph of these. By the way, there will be graph paper with your test tomorrow. That graph paper is to draw graphs on. I always get it back plain, or they'll do problems on it, make the graphs of their own graphs on their own paper. That's what we made, is try to make life easier for you. Okay, so what we're going to do is we're going to assign values for x. So let's x equal 1, -1, 3. Notice I just picked these numbers at random. I now want to find the corresponding y value. Well, if x is 1, what will y be? Tony?
3.
3. Everybody see how you got that? You plug 1 in for x. 2 times 1 is 2, plus y equal 5, y equal 3. If x is -1, Tony, y is 7. And if x is 3,
-1.
y is -1. Now the way he got these is he just plugged this number in, whatever value he assigned for x, and determined what y was. Now we're going to locate all these points. Our first point is 1, 3, right there. Our next point is -1, 7. That's close enough. And our last point is 3, -1. And there's our line. Notice, for as bad as this line is, the graph is, the line came out pretty good. On graph paper, if you got a straight edge, it should pass through the heart of all of these. Remember, put the name on the line, and that's it. This is the three-point method. Let's take the equation 2x minus 5y is equal to 20. And I'd like to talk about the second method. The second method was called the intercept method. And what we're going to try to do is find out where this line crosses the x and the y axis. Now we know that when the line crosses the x-axis, that the y value has to be 0. Every point on this x-axis, y is 0. So when this line hits the y-axis, the x-axis, y has to be 0. If y is 0, that means you're going to lose the y term. And all you have is 2x equal 20, therefore x would equal 10. So you have this point right there, which is 10, 0. Our second, we want to find out where it crosses the y-axis. When it crosses the y-axis, well, x has to be 0. Every single point on the y-axis, x is 0. If x is 0, you lose the x term. You come out with negative 5y equal 20, therefore y would equal a negative 4. So there is where it crosses the y-axis. You have your line. And that was the second method, the intercept method. The third method is when the equation solved for y when it is solved for y, we use what's called the slope-intercept method. Now next semester this will be called the functional method. Now we know that when this line crosses the, where does this line cross the y-axis? 2. Remember, when you have it solved for y, the constant always represents the y-intercept. So we have one point, we know the line is going to cross the y-axis right there. We now look at our slope. The slope is the coefficient of x, which is negative 5/3. By slope we mean change of y over change of x. In other words, the numerator tells you how far to go up or down. Well, it says negative 5, that means go down 5. From where? Always from the intercept. This is your key-off point. You want to go down 5. The denominator of that fraction tells you how far to go to the right always. Well, it's 3. There's your 2 points. You have the line. You put the name of the line on the line, and you're done. So there are the 3 methods. Now the 3-point method and the slope-intercept method always works. The intercept method doesn't always work though. In order to use the intercept method, you have to have an x term, a y term, and a constant which is not 0. In other words, if you had something like y minus 2x equal 0, you could not use the intercept method. You could either use the 3-point method or solve it for y and use the slope-intercept method. The intercept here would be at where? 0, the origin. Your slope would be 2. That means up from 2 up, 1 over. You have your line. Okay? So you see, the intercept method does not work all the time. So we know how to graph linear equalities. We also learned how to graph linear inequalities. Example. I want to graph the linear equality 2x minus 3y is greater than 18. Okay? This is what we want to graph. Now the first thing we have to do is graph the equality 2x minus 3y equal 18. I'm going to take a look at 2x minus 3y equal 18. And we're going to graph that by the intercept method. If y is 0, x comes out to be 9. If x is 0, y comes out to be negative 6. So now I'm ready to make the line. Now we go back to the inequality. Question is, what kind of line are we going to draw here? Is it going to be a solid line or a broken line? Broken line. You see, in your inequality, if the word equal is in your sentence, it's solid. The word equal is not in the sentence, it's a broken line. See, if this was 2x minus 3y was greater than or equal to 18, we'd have a solid. But since the word equal is not in the sentence, it's a broken line. So you see this broken line represents 2x minus 3y equal 18. What this line does, it breaks up our blackboard into two areas. Above the line, below the line. On one side of the line, 2x minus 3y is greater than 18. On the other side of the line, 2x minus 3y is less than 18. We want to find out which side of this line we're going to be talking about. So we take a point and test it. Any point you want, as long as this point is not on the line. The easiest point to select is the origin. Now, whatever is true about the point you selected is true about every point in the half plane on that side of the line. In other words, if we select the origin and it makes the sentence true, every point on the same side of the line as the origin is makes it true. If this point, the origin, makes the sentence false, then the half plane we're talking about is on the other side of the line. So let's take the origin and let's plug it in. Let's take this point 0, 0 and plug it in. Well, if I plug in the origin here, I have 2 times 0 is 0, minus 3 times 0 is 0, is greater than 18. I get 0 is greater than 18. Is that a true sentence? Not today. So this point is not in the half plane we're talking about. This point is not in our solution set. Therefore, every point on this side of the line is not on in our solution set. Our solution set has to be on the other side of the line, and there's the area. Okay? We talked about functions. The function was a relation, and all relations are ordered sets of ordered pair, but it's a special kind. It's a relation in which for each element in the domain, there's one and only one element in the range. For each x, there's only one y. And that's all we mean by domain, is the set of all x's that you're allowed to use or that are being used here. And the range is the set of all y's we get when we use our domain. That's all we mean by domain and range. Not a difficult concept. The domain is what values of x can we plug in there. The range is what values do we get for y then. That's it. Okay? So let's suppose I have a function x squared minus 7x minus 2. And what I like to do is I like to find f of, let's say, 5.